Today we are going to discuss finite automata with output, and here we have two theoretical machines for this. The first one is Mealy Machine and second is Mealy Machine. Now the question is why? Why we need an automata with output? So this is simple automata, but here we have some output. So instead of accepting or rejecting, we give some output, meaningful output, and from that output you can have many purposes. You can use it for many purposes. You can use it for translation, and you can extract meaningful information from that output. So let's understand it with example. So here we have a Mealy machine, and in Mealy machine the output is written inside the circles, inside the states. So we get an extra output before reading a string. When we start traversing a string like this, we will start from the first starting state, and here we have output 1. So I write 1 here, then I read letter A. So for letter A I move here, and here I get 0. Then I read letter B. For B I stay on this state, and here again I get the output of 0. Then I read letter A. I move to this state, and I get the output of 1. Then I read letter B. So I go to this state, and the output is 0. So here we have 4 letters as input and 5 characters as output. So this first character is an extra, because the output is written inside the states, so it is an extra output. So let's see another example. Here we have this Mealy machine, and this Mealy machine will tell us how many times this substrings occur in the input. So let's see. Let's run this string, and here this WB occurs 2 times, 1 time here and 1 time here. So we have 2 ones, and all other outputs would be zeros. So we start from here, output is 0, so I write 0 here. This is the next output. Then I read letter A. For A I move to this state, and the output is 0 again. Then another A, output 0 again. Then another A, output 0 again. Then B, output is 1. Then A, output is 0 again. Then B, output is 0 again. Then B, output is 0 again. Then A, output is 0 again. Then A, output 0. Then B, output is 1. Then B, output is 0. So here we have 2 ones. So it means, so this is the output, and we get extract information from this output, and here we can conclude that the substring WB occur 2 times, because we have 2 ones here. So that was Mealy machine, and now we see Mealy machine. Mealy machine is also a theoretical machine with output, exactly same thing. The only difference is that here, instead of writing the output inside the states, we write the output on the edges, or you can say on the transitions. So here, instead of writing the output here, we're writing it here. So the benefit of this is that we do not get an extra output. So we get the output whenever we read a letter, not before reading the letter. So we start from here. For A we move here 0, then A 0, then A 0, then B 1, then A 0, then B 0, then B 0, then A 0, then A 0, then B 1, then B 0. So again here you can see we have two ones, so it means this string has two occurrences of this substring WB. So next we see another Mealy machine, and this is an increment machine. You give the input of a binary number and the output would be incremental number. Like if you input this number, that is 6, the output would be 6 plus 1 7. So let's see. Here we have, so it's our choice whether we design a machine to read from left to right or to read from right to left. We have designed this machine to read from right to left. So we read 0 first. So for 0 you move here and output 1. Then we have 1. So for 1 output would be 1 again. Then 1 output would be 1 again. So this is the output and this is equal to 7. So you can try other numbers as well and you will get an incremented output. So that was it. Stay tuned and thanks for watching.